Yeah, Divya, I just know you unmuted.
Yes, sir.
Okay, just give me a minute. I'm opening my PPT. Those are online. Are you able to see my screen?
Yes, sir.
Yes, sir.
Yeah. Yeah. Shall we get started?
Yes, sir.
I asked you to go through some concepts and come, no? What were they? Okay, electrostatic potential due to a dipole at axial and equatorial point. Then, okay. Other than the axial and the equatorial point. Okay. So I could see most of them didn't do it. Sanjay Panya, வேற ஏதாவது அப்லோட் பண்ணியிருக்கடா செக் பண்ண போதும். Tejas, what about you? You didn't go through, right? Why? You? Why didn't you go through? I asked you to go through only during the class time. Then if the class இருந்தா அந்த 1 hour spend பண்ணிருப்பல. அந்த 1 hour தான் நான் spend பண்ணேன். Next time this will not be a clip. Next time I'm not going to let you sit in the class also. I've already asked you guys about this thing and I gave you. Right? I told you the reason also for giving the pre-recorded content so that we can save the unnecessary time that is getting wasted in explaining the derivations. You can concentrate more on problems, right? You will also learn more. Shall we get started? So electric potential due to a dipole at axial point. See, those who have already written the note, listen to it for one last time again so that you can remember better. Okay. So at an axial point means what? We have a positive charge and a negative charge, right? Let's say I'm taking a point P here on the axis of this dipole. So for this dipole, how do we take the distance as it is taken to be 2a, and the center of the dipole, if I consider it to be O, then this distance is going to be a and this distance is going to be a. Am I right? So from the center to the point P, if I take this distance to be r, then how much is this distance? This is going to be r minus a, and this distance is going to be r plus a. So if I take this to be a and this to be b, then the at point P, potential due to the charge at A is given as 1 by 4 pi epsilon naught q divided by the distance, which is going to be r plus a. Similarly, the potential at point B is going to be equal to 1 divided by 4 pi epsilon naught into negative of Q divided by R minus A, right? So the total potential at point P is going to be equal to VA plus VB. So what is the value of VA? It is 1 divided by 4 pi epsilon naught into Q divided by R plus A. Here it is minus Q divided by R minus A. So Q is common. This whole thing multiplied with 1 by R plus A minus 1 divided by R minus A. Is the point clear? So R minus A minus of R plus A. So Q divided by 4 pi epsilon naught into R minus A minus of R plus A, the whole divided by R square minus A square. So R and R get cancelled. So what is that you're left out with? Minus 2A multiplied with Q. This is going to give me dipole moment, but there is a minus sign. I repeat, minus A is minus 2A. So 2A multiplied with Q is dipole moment, and there is a minus sign. The whole divided by 4 pi epsilon naught into, we know this approximation between R and A. R is very much greater than A. So R square minus A square is approximated to R square. So answer will be minus P divided by 4 pi epsilon naught R square. Right? This is where we need to be careful. When you calculate the potential, right, due to a dipole at axial point, you will get two values. You will either get minus P divided by 4 pi epsilon naught R square or plus P divided by 4 pi epsilon naught R square. That depends on to which charge are you taking that point closer to. In this case, I got minus sign because the potential due to the negative charge is dominating compared to the positive. Why is it so? Because the negative charge is closer to the point P. Had I taken this point P on the left hand side, then I would have got the answer in terms of plus. So that is why you can remember the magnitude. It is P divided by 4 pi epsilon naught R square. When you calculated the electric field, you got R cube. The denominator will be R cube. I am not talking about the numerator. For electric field at axial point, the denominator was R cube, whereas electrostatic potential, the denominator will be R square. Am I clear with that? Right? I can make a note of this. But I'll give very less time to copy because all this was supposed to be done by you at home. Make it fast. Right. So what will be the next topic, obviously? So potential due to a dipole at equatorial point. It's very simple. If I take this to be positive, this to be negative, right here, if I take this point as P, which is the equatorial point, from here I drop the perpendicular. This distance is R, this is O, this distance will be A, and this distance is also going to be A. Right? If I take this to be A and B, both are of same magnitude, Q, then BP is going to be root of R square plus A square, and AP is also going to be root of R square plus A square. So at point P, potential due to the charge at A is going to be equal to Q divided by 4 pi epsilon naught into this distance, which is root of R square plus A square. Potential at point B is going to be negative of Q divided by 4 pi epsilon naught into root of R square plus A square. So the total potential at point P is going to be equal to VA plus VB. If you observe, both are of same magnitude but opposite signs, so they get cancelled. So answer is going to be 0. So the potential due to an electric dipole at equatorial point is always 0, meaning on this line, anywhere you take a point, the potential at that point is going to be 0. Here, right. So the next point is about any other. So you need to calculate the electric potential due to a dipole at some random point. That point I would suggest you to refer the video because it's a very big derivation and I don't want to spend time on that. Okay, that part, make a note in your. Those who have not copied, make a note. Refer the video for electric potential due to a dipole at any point. Electric potential due to a dipole at any point other than the axial or equatorial. You will get P cos theta divided by 4 pi epsilon naught R square. Okay. So that part you can refer the video because it is big. I need to connect two concepts. I need to use properties of triangles and then explain it. So go through it. If you have any doubt, you can reach out to me. Now I'm going to concentrate on the next important topic, which is called as equipotential surface. Right. So make a note of this point, which is called as equipotential surface. So as the name suggests, equi means same. Potential is obviously, you know what is potential? Electrostatic potential. So surface means a two-dimensional surface, a two-dimensional shape. So if you take a two-dimensional shape, right, on which you are able to see that the potential at every point is the same. Right. So I'm sorry, a small correction. Surface can be either two-dimensional or three-dimensional. Right. So if you take a particular surface, on that surface, every point will have the same potential. So if you take a surface like this and you take some random points P1, P2, P3, and you calculate the potential due to a system at those points. If the potential of point 1 is equal to the potential of point 2 is equal to the potential of point 3, then this kind of a surface is said to be an equipotential surface. This is one way of understanding. Or if I do Vp1 minus Vp2, this is called as potential difference, right, is equal to Vp2 minus Vp3. So everything you calculate, it will come out to be 0. So there are two ways to define equipotential surface. What is it? If you take that surface, if the potential at every point is same, it is called equipotential, or the potential difference between any 2 points is 0, it is still called to be a equipotential surface. Okay. So that is where the definition comes. So the definition says potential at every point on it is the same. Second, that is the OR definition for it is potential difference between any 2 points is the any 2 points is 0. So potential at every point on it is the same, or potential difference between any 2 points is 0. Clear with this?
Yes, sir.
Yeah. Clear? Right. If this is how the equipotential surface is defined as, then we need to see the shape of equipotential surface for different sets of charges. Suppose you have an isolated charge. Unlike electric field, isolated positive or negative charge is going to have the same equipotential surface. Okay. If I take this positive charge, then the electric field is away from it like this. Right? Now, I need to define a surface around this kind of a charge distribution where the potential at every point is going to be the same. Right? So, if I take an isolated positive charge, obviously, where will the potential be same? See, potential due to a point charge is given as kq divided by r. When q is fixed and k is fixed, what should be the parameter that should be fixed to keep the potential same? Obviously, distance. So from this point charge, if I take a fixed distance, right, if I take a fixed distance like this, and I join all these points, then we get a shape. Right? We get a surface. This surface, on this surface, what is happening? The potential at every point is the same. So this kind of a surface that is existing around the isolated charge, I'm using the word again. It can be isolated positive or negative, right? This kind of a surface that is generated around the isolated charge is said to be the equipotential surface. There is the one that is said to be equipotential surface. So it takes the shape of a sphere. So it takes the shape of a sphere. That's only for isolated. Okay. So make a note of it. Shall I proceed? Now,
Yes, sir.
if I have a charge which is placed at infinity, if I place a charge at infinity, then the field lines are going to be parallel to each other. Right? For a charge which is placed at infinity, what will happen is I will have points which are falling along a straight line. Right? So this is one set that you're able to see on the plane. But imagine this is the ray on the plane. Similarly, you will have multiple sets of rays like this. Right? You will have multiple sets of rays in this manner, where when you join all those points, right? When you join all those points here, that forms a straight line at the top. And it forms a straight line vertically, right? When you join those two shapes, right, you actually get a plane. you get a plane, and this plane surface is going to act as the equipotential surface. Right, this is going to act as the equipotential surface when the charge is placed at infinity, or to be more specific, for uniform electric field. So for uniform electric field, what is the shape of an equipotential surface? It is planar in nature. For an isolated charge, what is the kind of equipotential surface? It is spherical in nature. Right? This is something that you will not be able to see. First of all, field lines itself you will not be able to see. Similarly, you will not be able to see the equipotential surface also. The only thing is, to build the concepts, we are taking these things into consideration because it will simplify our understanding. Are you able to understand? Right. So you can draw a set of parallel planes like this. Right? So here what will you get? You will get set of concentric spheres. Here you will have set of parallel planes. We get the set of parallel planes. Am I clear with this? Right. Obviously, the next two types of systems are supposed to be like charges and unlike charges. So when you take the like charges into consideration, so due to this like charge, there will be an electric field around it, right? So observe, if this was not there, what would have been the shape of the equipotential surface for this charge? It would have been spherical, right? So you would have had something like this. What about this? You would have had spherical, right? So after this, what will happen is they are merging, right? They will not intersect each other and cut each other at 2 points. Rather, they'll be like this, right? So this is the shape of equipotential surface due to system of like charges. When I say system of like charges, don't think I've drawn positive charges here. That is why I drew it like this. Even if it was a set of negative charges, the equipotential surfaces would have been of the same nature. The only thing that will change is the direction of electric field. Because electric field due to a positive charge is away from it, and electric field due to a negative charge is towards it. That has direction. This does not have any direction. It's just a shape. Am I clear with this? So this is for a system of two like charges. This is for a system of two like charges. Similarly, when you have a system of unlike charges, what will happen is that's it. There will be no layer of this sort. This is for a system of two unlike charges. Am I clear with this? Clear?
Yes, sir.
So this is very, very important. Let it be. There's only an equipotential surface. No? Because what did we see in the case of a dipole? Equipotential surface rate was 0. And I did a problem also. Remember, whenever you have a system of unlike charges, there will be one point in between them where the potential will be 0. So another, the surfaces cannot cross that point. Clear with this? So based
Yes,
on
sir.
this, we will be, based on this, we'll be seeing the relation between field and potential. So we'll see the relation between field and potential. Okay. So this is a very, very important concept. Suppose I have two equipotential surfaces of this nature. Meaning I have one sphere like this, another sphere like this. From those two spheres, I've taken apart. And let's say they both are like this. Okay. And let's say there is a test charge Q naught, which is being moved from this point to this point. Okay. Let's say these kind of equipotential surfaces are produced due to a positive charge here. Q. It's not Q naught, it is just Q. There is some positive charge Q due to which these two equipotential surfaces are fixed or generated. So Q naught is moved from the equipotential surface 1 to the equipotential surface 2. Okay. So here, if I take the potential to be V, then what will happen to the potential here? Will it decrease or increase? This potential is generated due to this charge. So greater is the distance, lesser is the potential because it's inversely proportional. So here, if it is V, here it will be V minus delta V. Am I clear with this? Right. Now listen to this carefully. Whenever I need a relation between field and potential, right? Field is a concept related to force. Potential is a concept related to work done. Okay. So what I'm going to do in this scenario is I'm going to calculate the work done to move Q naught from first surface to second surface. So I'm moving it in this direction. Right. So W, the amount of work done to move Q naught from 1 to 2. Right. So I'll calculate the work done by force. So if you see the work done by force is going to be equal to Q naught multiplied with E, which is the force, multiplied with the distance between them, which is going to be delta X. So force multiplied with delta X into force is in this direction because it's a positive charge. Electric field is like this. Force is in this direction. Displacement is also in the same direction. So F into S into cos of 180 degrees. So Q naught into E into delta X. Sorry, not cos 180. I'm sorry. Sorry, cos 0. So Q naught into E into delta X. So this is going to be the amount of work done by the force. What is the amount of, so how is this work done going to get stored? It will get stored in the form of change in potential energy. So what is the change in potential energy? It is final potential energy minus initial potential energy. So what is the value of final potential energy? It is the charge multiplied with the potential. So Q naught into V minus delta V minus initial potential energy is Q naught into V. So V and V will get cancelled. So what is that you're left out with? You're left out with minus Q naught into delta V. Am I clear with this? Minus Q naught into delta V. Let me call this as equation number 1. Let me call this as equation number 2. So work done by the electrostatic force is getting stored as the change in the potential energy. So what I can conclude from here is W is equal to delta U, which implies Q naught into E into delta X will be equal to negative of Q naught into delta V. Q naught and Q naught will get cancelled. So what are you getting? E will be equal to minus delta V divided by delta X. So if you observe, electric field is observed to be negative of this delta V by delta X. Remember, this delta V or change in something with respect to distance. If you look at delta x, no, that is distance. Changing something with respect to distance is given a name called as gradient. So you call this as gradient of whatever value is in the numerator. It's called as potential gradient. What do you call it as? Potential
Potential
gradient.
gradient.
So you say electric field is equal to negative of potential gradient. Electric field is called as the negative of the potential gradient. I'll explain what is the significance of that minus. Let's see. Is that clear? So make a note, make it fast. This is a very, very important concept. Clear? So here, make a note. Negative sign indicates that the electric field, negative sign indicates that the electric field is always in the direction of decreasing potential. Electric field is always in the direction of decreasing potential. Okay, I'll explain the meaning of it. Right? I repeat, the negative sign here indicates that the electric field is always in the direction of decreasing potential. So what is the meaning of it? Meaning, if I have a positive charge, for instance, and let's say I have a negative charge. So due to the positive charge, this is how the electric field lines are. And due to the negative charge, this is how the electric field lines are. Right? If suppose I take a point A here and B here. Suppose I take a point P here and Q here. Okay. So if I calculate VA, let's say the magnitude here is Q. So what is going to be the value of VA? It will be Q divided by 4 pi epsilon naught R1. Suppose I take this to be R1, and if I take this to be R2. What is the value of VB? Q divided by 4 pi epsilon naught R2. Have this in your mind. What about the values here? VP will be equal to negative of Q. If I take the value to be Q here, let me say this distance is R1 and let me say this distance is R2. So minus Q divided by 4 pi epsilon naught R1. What about VQ? Minus Q divided by 4 pi epsilon naught. Clear? No. What will be the relation between VA and VB? See, Q by 4 pi epsilon naught is common in both. 1 by R1 is there, 1 by R2 is there. Lesser is the denominator, more is the value. So among R1 and R2, which one is lesser? R1. Or another logic, closer the point, greater is going to be the magnitude. So in this case, can I say VA is greater than VB? Makes sense. Right. 1 by R1 is greater than 1 by R2. VA is greater than VB. What about this? It is minus Q divided by 4 pi epsilon naught R1, right? So Q divided by 4 pi epsilon naught, if I take it out, minus 1 by R1. See, observe, R1 is less than R2. Am I right? 1 by R1 is greater than 1 by R2. We know that when you take the reciprocal, the inequality changes. When you multiply with minus sign on both the sides, minus 1 by R1 will be less than minus 1 by R2. So I'll multiply with Q by 4 pi epsilon naught on both the sides. So minus Q divided by 4 pi epsilon naught R1 is less than minus Q divided by 4 pi epsilon naught R2, meaning VP, this is VP, is less than VQ. Whereas here, what is happening? VA is greater than VQ. So in both the scenarios, if you observe, right, is the electric field not always going in the direction of decreasing potential? A is greater than B. So this is the direction in which it is going. Here, Q is greater than P. This is the direction in which it is going. Am I clear with this? Are you able to understand? So this is the meaning of the negative sign that is given. Am I clear? Yeah. So make a note of this. Can I proceed? Right. So there is a very, very important problem from your textbook, which is example 2.3. That is in page number 59. Right. So figure 2.8a and b shows the field lines of positive and negative charge respectively. Okay. So if I take the positive charge, due to the positive charge, obviously the field lines are going to be away. Okay. Okay, accepted. Now there are 2 points, P and Q. Similarly, due to the negative charge, The field lines are towards it, and there are 2 points, A and B. Okay. So the first question is, give the signs of the potential difference Vp minus Vq. So first, they're asking what is the sign for Vp minus Vq and Vb minus Va. It is obvious. So what did we discuss? Electric field is equal to negative of potential gradient, and the negative sign indicates that the electric field is always in the direction of decreasing potential. So among P and Q, which one should be at a greater value? Obviously, Vp should be greater than Vq, only then electric field is in the direction of decreasing potential. So if I bring the Vq to the left hand side, Vp minus Vq will be greater than 0. Greater than 0 means it is going to have a positive sign. In a similar way, if I look at the negative charge, electric field is in the direction of decreasing potential. So which one is greater? Vb is greater than Va. Vb is greater than Va. So Vb minus Va will be
Negative.
greater than 0. Vb minus Va will be greater than 0. Again, this is also positive. You're able to understand that one negative sign will actually help us to solve many problems. It's not yet done, but I hope you could understand this, right? So the next part of the question is, give the sign of the potential energy difference of a small negative charge between the points Q and P and A and B. Give the sign of the potential energy difference of a small negative charge between the points Q and P, meaning UQ minus UP is what they are asking. Okay, so what do you have? You have a negative charge. The negative charge is moved from where to where? From. So give the sign of the potential energy difference of a small negative charge between the points Q and P. So what is going to be the value of UQ? It is going to be minus Q times VQ, because potential energy is charge multiplied with the potential Q into V, minus what is the value of UP? Minus Q into VP, right? So if I take the Q outside, or I'll take the minus Q itself outside, then what will I get? I'll get VQ minus VP, because I took the minus sign outside, this minus will be with VP. We know that VP minus VQ is positive, then VQ minus VP will be negative. So here you have a negative value, here you have a negative value, negative into negative will give you a positive value. Means when you move a small negative charge and between the points P and Q, then UQ minus UP is going to give you a positive value. Okay, this problem is very important. Make a note of this. Okay. And they asked between A and B. Listen to this. So UA minus UB. Same logic. Minus Q VA minus of minus Q VB. So if I take out the minus Q outside, then VA minus VB. But what is VB minus VA? VB minus VA is positive, so VA minus VB will be negative. So you have a negative here, multiplied with another negative is going to give you positive. That's it. So in both the scenarios, you will get a positive value. Clear with this?
Yes, sir.
Yeah. A minute. Okay. The next part of the question is, give the sign of the work done by the field. See, whenever there is a question based on work done, if they put a question like this, tell me the sign of the work done. Okay, the question is wrong. They need to say work done by which force. In this case, they have clearly mentioned, give the sign of the work done by the field in moving a small positive charge from Q to P. So Q to P means here. So there is a small positive charge. That positive charge is moved from Q to P. What is the work done by the field? Okay. Here, rather than calculating the work done, they ask what is the sign of the work done. It's very simple. So we know that work done is directly proportional to the angle between force and displacement. So the question is very clear. What is the work done by the electric field? Electric field is in this direction, right? And you have a positive charge. What will be the force experienced by the positive charge due to the electric field? It will be in the rightward direction of Q into E. But in which direction is the displacement taking? This direction, from Q to P. So force and displacement are in opposite direction. So what will be the angle? It will be 180 degrees. Cos of 180 is going to generate a negative value. So work done by the electrostatic field when the charge is moved from Q to P is going to be negative. Clear with this? Okay. So listen to this, then I'll give you time to write. The next part of the question is, give the sign of the work done by the external agency. External agency means something which is opposite to the electric field. Work done by the external agency in moving a small negative charge from B to A. So what you have here? You have a negative charge. The negative charge is moved from B to A. Right. So this is the direction of electric field. This will be the direction of external force, because external force is always applied in the direction opposite to the electric. Right. So what will be the work done? See, let's calculate due to the electric field. Due to the external agent, it will exactly be the opposite. Can I say that? So this is the direction of electric field. But in which direction will it experience a force? So this will be the direction in which this charge will experience a force of Q into E. So what will be the direction of external force? Make sense? Now read the question. Give the sign of the work done by the external agency in moving a small negative charge from B to A. So this is the direction of displacement. And this is the direction of force by whom? Force by the external agent. So since they both are in same direction, theta is going to be 0 degrees. So when it is going to be 0, work done will be. Had the same question been, what is the work done by the electric field? Then the answer would have been negative. Okay. So since it's external agency, it is positive. Does it make sense? Right? And the last part of the question is, does the kinetic energy of a small negative charge increase or decrease in going from B to A? So, does the kinetic energy of the small negative charge? So, small negative charge, when it is moved from here to here, is its kinetic energy going to decrease or increase? Is what the question is. How? So, work done by is equal to change in kinetic energy. What did I apply here? This is called as work energy theorem. So this is called as work energy theorem. So work done is equal to change in kinetic energy, because here the question speaks about change in kinetic energy. That's why it had to apply it. Okay. So here, what is going to be the work done by the external work done by the electrostatic force? Is it going to be negative or positive? See, when the work done by the external agency is positive, work done by the electrostatic force will be negative. So negative is equal to change in kinetic energy. K final minus K initial. If final minus initial is coming out to be negative, then what does it mean? Then K final is less than K initial. Hence, the kinetic energy is decreasing. See, it's very simple. I hope you are able to understand why it is decreasing. Even if you don't know work energy theorem, let's assume you don't know. Logically think, you have a negative charge here and the source charge is also negative. It will obviously repel. If something has to move against electric field, what will happen? Obviously, its energy will decrease. See, imagine there is a magnet here. Okay. Imagine this. Okay. If at all you don't get idea with respect to charges, right, I would suggest think in terms of a magnet. So when you take a magnet, let's say you have a north pole here, south pole here, this is fixed. Okay, I'll take another magnet. I have north pole here, south pole here. What was there here? North pole. Here, what do you have? North. So I throw this towards it. What will happen? It'll, with the energy that you have given, it will try to travel. But as soon as it comes closer, the amount of repulsion it will experience will be more. Means there will be one particular instance where it will stop and then change its direction. So if something has to stop, what should happen to its kinetic energy? It should decrease or increase. That's what is happening. Simple. You throw a ball upwards. You gave velocity. It's going upwards. At one point, it is going to rest, then changing its direction. What is happening? It's decreasing. Same logic. Okay, I tried to prove it mathematically, but you can give this logic also. Is it clear?
Yes, sir.
Yeah. How many of you have exams in school? When? Next week. How many chapters? 3 chapters are over. How come so fast? May 2nd onwards, we have exam. Till May 2nd, May 12th வரைக்கும் ஸ்கூல் இருக்காப்பா? For you, when is it closing? Till June? June 5th they are opening or 4th? 5th only they are opening. How many chapters are over? What about you, Dan? Exams are going on, huh? Okay, which chapter? Then you know this chapter, huh? What about you? So June they are starting. Hari Raghav, what about you, Dan? Next week it's starting. Which chapters? First chapter. Everybody got the book, right? Got the material, no? Next class onwards, carry that. Because there are MCQs in that book. I want to solve more on that. And I repeat it again. Next time onwards, if I'm giving you recordings, work at home and come. If not, don't come at home. I don't want to shout in front of others. I'm treating you like college guys. I don't want to insult. I want to treat with respect. You also safeguard it. முடியலன்னா வராதீங்க. Okay, I'm checking. I checked the app. I saw most of you didn't write it. The reason why I'm saying don't come is because it is an insult to people who have worked at home and come. I had to repeat certain topics, others were sitting idle. I hope you understand. If you work and come, you'll know what is the pain. You have already worked once, again listening to the same topic again, you know how the pain will be. புரியுதா நான் சொல்றது? This will be the last warning. I'll not shout, but I'll just say politely you can leave. நான் எதுவுமே கத்த மாட்டேன். I'll treat you with absolute respect. புரியுதா? உங்க மரியாதை நீங்க காப்பாத்திக்கோங்க, என் மரியாதை நான். That's mutual respect. Is that clear? So next time onwards, I want that to happen. And I want to solve more problems. Because in fact, I wanted to ask you what is the help you need. Because I can see most of you have exams, right? I wanted to find out if there is anything that I can help you with. But இருக்கிறதே நீங்க பண்ணல. You're not managing time properly. I'm repeating it again. August மேல you'll have a lot of record works. That nonsense, this nonsense, time will get wasted like anything. They'll not complete the syllabus, they will rush in the last minute. I don't want you to go through that. It will happen in your school for sure. Okay. But at least you worked and came, so I have no complaints about it. I'm saying you're sincere. No, that is enough for me. You be like that, that's enough. I can take care of the rest. Is the point clear? Did you write? Well, next time don't do it. Okay, now? Then do no. So I'm saying next time, please don't do it. Because for your benefit, I'm giving and to save time. I think we had a mutual consent and only I gave that work. I didn't force anything. I asked you guys and I told you the reason why I'm giving it. Right? It's your responsibility to save time. The time is very important. Work next time, I don't want any excuses. Forgot, sir, record work. I don't know. Mostly I'll give it only in the weekends. If you don't know, do night out. What other work you have? Nothing, no. When I can do it, you can also do it, right? 1 year you are working, that's it, right? Do it and come. Clear?
Yes, sir.
Yeah. So we'll end it. So I'll see you all tomorrow.
Thank you, sir.
Yeah. Board exam, last year board. MCQs, assertion reason. 40. என்னாச்சு? Relations and function physics test, electrostatics. Full chapter. 6:15 to 7. Oh, no, the online level. 3 marks. 40 marks. Same as MCQ. Assertion reason. Okay. 2 marks, 3 marks subject, 4 marks on the case-based questions. 5 marks or 5 marks கொடுத்திருக்கேன்னு நினைக்கிறேன். It's exactly half கிடையாது. 70, half 35 இருக்கும். But I wanted to set it for 40, but I'll give you only 1.5 part. 1.5. Half here. It's actually 35 கொடுக்கணும். I set it for 40. It's just a stress test for you to learn time management. So yeah, you can fail multiple times here, no issue. Exam ஆகாது. Hello. Lateral shift and normal shift புரியலையா? எதுல? இல்லடா, எந்த கிளாஸ் லேபா?